So good evening everyone and welcome to this astonishing lecture. And what we are doing, we are dealing with series and parallel combination, and I think from capacitors we had also moved on to resistors. Remember the questions, whether it's a question on capacitor or whether it's a question on resistor, the concept remains same. Do we remember this? Yes or no? We were doing some questions and we will continue on that in this class. The more you practice, the better you are going to be. Whether it's a question on capacitance series parallel or it's a question on series parallel of resistance, is the same concept and the same question. So let us not waste any time and move on to this question. Again, this is taken from your favorite book, and this is question number 13 from your book. Page number what I have is 189. So we have to find the equivalent resistance between A and B. Page number 189, question number 13. Find the equivalent resistance between the points A and B of the network. It's a pretty simple question from where I see. What is the answer for this one?
6 ohms, sir.
The answer is 6 ohms, sir. That is correct, sir. How did you get the answer? 6 ohms. This 4 and this 2 are in series. So 4 plus 2 becomes 6. Then this 6 and this 3 will be in parallel. 6 and 3 in parallel in resistance becomes 2. Then again 2 and 4 in series becomes 6. 6 and 3 in parallel again becomes 2. 4 and 2 again in series becomes 6. So again it is of the same type that we had done. Series parallel, series parallel, series parallel combination, starting with series, then parallel, then series, then parallel, and so on. As you can see, the type of question that we get are of the same concept. If you understand them once, you should be able to do them again and again and again. Everyone got this? Yes or no?
Yes, sir.
That is the next question now. Question number 14 from the same page. And this one, find the capacitance, no, find the resistance between A and B in the figure. I hope you have got the book so that you don't have to draw the diagram, you just have to calculate the answer and give me the value. No one has the book. Great. Anyways,
6, sir. 6 ohms.
6 ohms. Huh? The answer that I have is 2 ohms. Between A and B, you have to calculate. Shall I do
Sir.
it?
Sir, we got 2.
We got 2. Well done. How are you supposed to do this? 3 and 3 in series becomes 6. 6 and 6 in parallel becomes 3 again. 3 and 3 in series becomes 6 again. 6 and 6 in parallel becomes 3 again. 3 and 3 in series becomes 6 again. 6 and 6 in parallel becomes 3 again. 3 and 3 in series becomes 6 again. And this 6 is in parallel with this 3. 6 and 3 in parallel, the answer becomes 2 ohms. So the answer for this one is 2 ohms. Again, it is of the same type: series, parallel, series, parallel, series, parallel, and so on. Do we understand this? Series, parallel, series, parallel, series, parallel combination. 3 and 3 in series, then they are in parallel, then they are in series, then they are in parallel, then they are in series, then they are in parallel. Anyone understands this?
Sir.
The more the practice that you are going to do, the better you are going to be. This is the next question. This is question number 15 from the same page. You have to find the equivalent resistance of the network between points A and B. First case, switch is open. Second case, switch is closed. So that is the difference between the two cases. I'll give you 2 minutes to give me the answer in both the cases. So how are you supposed to do it? When the switch is open, switch is not connected, then these two switch is not connected. These two are in series. 6 plus 12, 6 plus 12 becomes 18. These two are in series. This is also 18. 18 and 18 are in parallel. So the answer is 9. That is the answer when the switch is open. 6 and 12 are in series. 12 and 6 are in series and they are in parallel. So the answer becomes 9. Do we understand this? Yes or no?
Yes, sir.
Then you move on to the next case. In the next case, this switch is closed. Now, when you have this switch closed, what happens? These two come in parallel. 6 and 12 are in parallel. 6 and 12 in parallel gets you 4. 12 and 6, these are also in parallel now because they are connected. One end is connected to one point and the other end is connected to other point. So 6 and 12 are in parallel, the upper one and the lower one. 12 and 6 are in parallel, the upper one and the lower one. Then they are in series. So the answer in that case is 8. That is the change that has been caused by the switch being opened or the switch being closed. We understand this? Switch being open, they are not connected in between. Switch closed, they get connected in between and they come in parallel. We understand this now?
Yes, sir.
Everyone, girls, boys together. We understand this?
Sir.
Yes, sir or no, sir?
Yes, sir.
Pakka na, sir? Okay. Take your time. Please take your time and do it. Again, it all depends on how much you practice. The more you practice, the better you are going to be. And that is why I'm doing all. Remember, we are doing it once. We are not going to do it again. You have to find the equivalent resistance between A and B. This is question number 17 from the same page. What is the answer for this one? It's a simple one. All the questions are simple. I've told you. All the questions are simple.
20 ohms, sir.
20 ohms, sir. Everyone got the answer? Not getting responses as quickly as I was expecting and as much as I was expecting. One more minute for everyone to understand what we are doing. How this is done? Tell me. How did you do this?
Wheatstone bridge, sir.
This is a Wheatstone bridge, sir. Yes, it is a Wheatstone bridge. V-stone bridge. Therefore, the central resistance, you can see here, 15, 30, 15, 30, R1 by R2, same as R3 by R4. So this beach wala will go off. Now you can do it in any way that you feel like. You can take these two as the pink one as parallel, and then other in parallel and then in series, or this way I find it easier. I will take these two in parallel series, these two in series, 15 and 15 in series, 30, 30 and 30 in series, 60, 30 and 60 in parallel. The answer would be 20 ohms. No matter how you do it, you will always end up with the same answer. Do we understand this, or this has gone above our head saying bye bye? It's a V-stone
Understood,
bridge,
sir.
same concept. Don't take it as resistance or capacitance. They are the same concept. C1, C2, R1, R2. Instead of microfarad, you are now having ohms. That's the only difference. We understand this, yes or no?
Sir.
I'm not seeing enough confidence
Yes,
in
sir.
your thing. We understand this.
Yes, sir.
Shall we move on to the next one?
Yes, sir.
Yes, sir.
Pakka? Yes.
Yes, sir.
Okay. Let's see. There are a lot of questions that we have, and the more the number of questions that you solve, oops, the better you are going to be. This one, for example, and I'm not going to tell you the page number because there is no point. You don't have the books, right? I think this is question number 21. You have to find the effective resistance between A and C. Each resistance is equal to R. Each resistance is R. You have to find the equivalent resistance between A and C. Can I expect an answer for this one or not?
4 by 3, sir.
Chalo. Good. Answer is 2R by 3. That is absolutely correct. I think we have done this question in capacitance as well. Yes or no?
Sir.
So that brings us to the same fact that whether it is a question in capacitance or whether it's a question in resistance, the concept remains exactly same. First part and the next thing, if you do enough questions. Shall I explain how this is done? These are two two V-stone bridges that you see. So this one and this one will get cancelled. I mean, not cancelled. They will not come in the circuit. Now you can do it in any ways. These two are in series. These two are in series. These two are in series, and then all of them are in parallel. R in series. 2R, 2R, 2R. 2Rs in parallel. 2R by 3, and 2R by 3 is the answer here. Yes or no?
Yes, sir.
Okay, let us move ahead and solve more. Remember, the more the number of questions you are going to solve, the better you are going to be. Where is the next question coming from? Where is it? Where is it? Where is it? Where is it? This one. We have already done this, but again, give me the answer fast so that this entire book is covered. This one. Yes, what is the answer for this one? You need to find the equivalent resistance between A and B.
R by 3, sir.
R by 3, sir. Why it is R by 3, sir? Because it is same as the capacitance. If this point is A, this point also
Parallel
becomes
connections.
yes, they are connected in parallel. This point is B, this point is B. All these resistors are connected between A and B. Basically, they are connected in parallel. 3 resistors R connected in parallel, the final answer would be R by 3. We understand this, everyone?
Yes, sir.
Then comes the next one. Okay. What about this one? The resistances are not given, so you can take them as equal. All the resistances are equal. How do we solve this one? The next question. Is there anyone who's going to give the answer for this one or not? So much of time? Why? Is it such a difficult one? Shall I do it? No one for this one? Okay, must be tough then.
Sir,
Yes.
4R by 7.
4R by 7. How did you get 4R by 7? Can you elaborate? How did you
R
get
by 2, sir.
from 4R by 7? The answer drastically changes to R by 2, which has got no relation with each
Sir, we
other.
got R.
R by 2, I think, is the correct answer. So from 4R by 7, how did the answer drastically change to R by 2? That is what I want to understand. How are you going to do this? Yes. Jokes apart. How are we going to do this? No one. Each resistor is R, 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 R. I've just drawn these 5 because looking at these 5, you must realize something. What you must realize looking at these 5?
Wheatstone bridge.
That this is our favorite Wheatstone bridge. So this goes out. This R and R come in series, 2R. The same as capacitance. This R and R come in series, 2R. 2R and 2R come in parallel, R. Then R and the last R also come in parallel. So no way I can get 4R by 7. The only answer I can get is R by 2. Do we understand this?
Yes, sir.
See, it is so simple, sir. Isn't it?
Yes, sir.
Why I'm not getting the answers as quickly? What has happened? Everything is okay? Your health is okay, everyone? Everyone feeling good? Everyone feeling good or not?
Feeling good, sir.
Then why not the answer coming, sir? This one, sir. You have to find the equivalent resistance between A and B. I'll give you 2 minutes to give me the answer. It again comes from the fact. Remember, you have to find out the resistance between A and B. So what do? I put this to find out between these 2 points. So this R and this R will come in series. It will become 2R. 2R and this R will come in parallel. So it will become 2R into R. divided by 2r plus r, 2r by 3. 2r by 3 and this r will come in series. So 2r by 3 with r will be 5r by 3. Then 5r by 3 and this r will come in parallel. So the final answer would be 5r by 3 into r divided by 5r by 3 plus r. And that is the answer you will get. And I think you are going to get how much? 5 by 8 r. 5 by 8 r should be the answer. How did you get that answer? Everyone understands how this is done? This is again that series parallel stuff.
Understood, sir.
Why are you not able to get the answer, sir?
We got the same, sir.
Got it?
Yes,
Boys,
sir.
you got r by 2. How did you get r by 2? Do we understand this? Huh?
Yes, sir.
What, sir? I'm getting worried about you, sir, now. Now, remember the difference in the point. If I change the point, and if I put the point B here, then the question is totally different. See, if I put the point B here, now what is the answer? Now remember, one point A is here, the other point B is here. Now what is the answer? It all depends on between which points you are finding out. It all depends on between which 2 points you are finding out the effective capacitance or effective resistance.
R, sir.
Yes, now it becomes a valence Wheatstone bridge. You understand? Now it becomes a balanced Wheatstone bridge. Now the answer is R. So between A and B, the answer is R if they are diagonally opposite like this. But when they are put in that way, the answer is different. Why is the answer different? Because the points are different. I hope you understand the concept. Yes or no? Okay. This one. You have to find the effective resistance between A and B. I'll give you 2 minutes. Well done. That is the answer, 4R by 3. How are we supposed to do this? See, this is point B. And this red thing, this pink thing is nothing but same wire. So all these points are actually B. So you can write this point also as B. This point is also B. And this point is also B. Now let me call this point as C. So if I redraw the circuit, if you want to redraw, between B and point C, you will have 3 resistors connected like this. Resistor number 1 here, resistor number 2 here, resistor number 3 here. Then you have this point C, and between C and A, you have one more resistor R, which is this yellow one. The yellow one is here. Now you can very easily see R are in parallel, so it is R by 3. Then that is in series with R, so it becomes 4R by 3. The final answer becomes 4R by 3. How many of you got this? Can I have you raise hands that we got this? 1, 2, only 2. What about the others? Okay, great. This one then, and I want the answer quickly now. I hope you can pick up some speed. If you are not able to do it quickly enough, I will have to cut short some problems, right? Because you cannot go on with the same process till infinity. There's a point where I will have to cut short. Yes, this one. What is the equivalent?
R/3, sir.
Think, 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 think.
R/4, sir.
R/4, sir. That is correct, sir. How do we get this R/4, sir? See, all these points are B.
Parallel connection, sir.
This is B, this is B, this is B, and this is also B. Between A and B, all these four are connected between A and B. So they are connected in parallel. It becomes R/4 without any other complication. One more. Do it fast. This one.
R, sir.
The answer is R, sir. That is correct, sir. You have to find the equivalent between this point and this point, this point and this point. And as soon as you look at these 2 points, you understand that this is a balanced Wheatstone bridge. So both of these will get cancelled. R and R come in series, R and R come in series, and they come in parallel. So the answer is simply equal to R. We understand this, everyone? Yes or no?
Yes, sir.
Okay. Let us move on to the next one, and then we'll move on to the next category. This one, I think we have already done this, but still, just to refresh the memory, what is the equivalent resistance between A and B in this case? Everyone knows this, I guess.
R, sir.
The answer is R, sir, because this again forms a what? It again forms a balanced Wheatstone bridge. Do we remember this?
Sir.
So this will go away, and you, since all are R, you will end up with R because we have done so many questions where all were R and we ended up with R. So we understand this. Now let me take this one. And to solve this one, we might be required to do same thing, but probably in a different way. This one. I'll give you 2 minutes to think about this. You have to find out the effective capacitance, effective resistance between A and B. I'll give you 2 minutes to think about it. Now remember, whenever we are solving questions on effective capacitance or effective resistance, if you remember, one concept that we had done was in Gauss law, and I told you in Gauss law, symmetry plays a very important role. In Gauss law, similarly, symmetry plays a very important role in questions of this nature. In questions of resistance and in the questions of capacitance, where you have to find out the equivalent resistance and equivalent capacitance. Symmetry plays a very important role. Now, we understand symmetry, and then once you understand symmetry, you understand that you can solve the question in different ways. Now, do you see a symmetry in this diagram? Do you see a symmetry in this diagram? Yes or no? Do we see a symmetry in this diagram?
Yes, sir.
Okay. Now let me try to make you understand this symmetry. Now, since we have to find out the potential, the equivalent capacitance, equivalent resistance between point A and B, if I imagine that a current I is coming from here. Now, when it comes to I, it has got three different paths to go. Let us say in the path, the above path, I1 goes. What will be the current that will go in the lower path? Remember,
I2.
the upper path and the lower path, they're exactly same, yes or no? So if I1 goes in the upper path, I2, I should not call it I2 in fact. I should call it, since I understand the symmetry, I should call it I1 because the same current should go in the lower path. Yes or no? Because the upper half and the lower half, there is symmetry there, right? Everything is same. So whatever current goes in the I1 part, the same current has to go in the lower part. Yes or no?
Yes, sir.
That makes things a lot easier. So whatever current goes in this part will not be different. It will not be same. It will be different. I2. Now, since we understand symmetry, now from here I can now do it in a variety of ways. Once you understand this, now I1 is going like this, and this I2 is going like this, and again same I1 is going like this. Now that brings us to this point A and this point B. Now you must understand, since the current and the resistance is same, this point A and this point B will also be same potentially. Yes or no? Same potential drop will happen and point A and point B will be same. Yes or no?
Yes, sir.
Similarly, all the other points, if I call this point as C and this point as D, point C and point D would be same. Yes or no?
Yes, sir.
Okay. Point C and point D will be same. Okay. Now we are going to do some problems by this, understanding the same points, but we are not going to do this by understanding the same points. I was just trying to make you understand that the points are same. Okay, I1 current goes in the upper branch, and logic will tell us that the same current I1 should come back from this branch because there is symmetry. The same current I1 which has gone in the lower branch, the same current I1 should come back from the lower branch. Why? Because there is symmetry. It is symmetrical in this aspect, it is symmetrical from that side also. Do we understand this?
Yes, sir.
Now, if I1 is going in the upper branch and I1 is coming back from the upper branch, that means this current I2, which was coming in the middle branch, just goes like this. Yes or no? This current I2 just goes like this straight. Yes or no? Then only things will happen correctly, right? I1 has gone in the upper branch and it is coming from the upper branch. I2, same I1 has gone in the lower branch. It is coming from the lower branch. That means these current are not meeting at all anywhere. Do we understand this?
Sir, why won't the current flow from A to D?
Because it will not flow because of symmetry. That is what you have to understand. That is what I'm trying to make you understand. That I1 goes in the upper branch, I1 goes in the lower branch, I1 comes back from the upper branch, I1 comes back from the lower branch, and therefore this green current just goes through. Now, what do you mean by this green current going through? That means these two resistors, we can assume that they are not connected to the main center. They are just connected like this. So this connection gets disappeared and you have one branch like this and the other two branch are completely separate of each other. Now once they are completely separate of each other, it's simple to understand that current here will break into two branches. Then it will again, same current will flow from here. It will just flow like this. in here it will just flow like this and it will go. Do you understand what is happening here? It's because of symmetry, beta, and that is the only way you can understand it. Now you can understand how these are connected. Now whatever resistance you are going to get for the upper branch, the same resistance you are going to get for the lower branch. Yes or no? So what is the resistance that you are going to get for the upper branch? These two blue, this two blue are in series because the same current flows. So R and R becomes 2R. These two are in parallel with this. So 2R and R are in parallel. 2R and R are in parallel. It becomes 2R by 3. Yes or no?
Yes, sir.
Then this 2R by 3 is in series with the other two. So that becomes 8R by 3. 2R by 3 plus 2R. So the resistance of the upper wala branch becomes 8R by 3. The resistance of niche wala branch becomes 8R by 3. This 8R by 3, this 8R by 3 are in parallel. So it becomes 4R by 3. This green branch, these two are in series. So this green branch becomes 2R. The upper branch is 8R by 3. The lower branch, oops, wrong color. The lower branch is also 8R by 3. And all of these are connected in parallel. That will give you your answer. Do we understand how this is done?
Sir,
Yes.
once can you repeat it again?
What have you not understood? Which part?
8R by 3.
8R by 3? Do it on your own. Just take the upper branch out, take it out and do it. That is the best way to do it. Take the upper branch out and do it on yourself. R and R are in series, the blue ones, that is 2R. 2R and R is in parallel, that is 2R by 3. 2R by 3 is in series with the slanting ones. 2R by 3 plus 2R, that is 8R by 3.
Understood, sir.
See, it's simple. Anyone else who did not understand it? Upper branch is different, it's separate. Lower branch is separate and the central branch is separate. And why they are separate? Just because of the symmetry of the entire thing. Do you understand this? Everyone in the class?
Yes, sir.
We are good, sir?
Understood, sir.
Pakka?
Yes, sir.
I'm not getting the real pakka. Okay. So this is how you understand symmetry. If you understand symmetry, even tough problems, you will be able to do them quite quickly. Now this is one that I'm going to give you. Again, remember the concept remains same. How I apply that concept is what you have to understand. And whenever you are going to get a question on series parallel combination, it will be based on symmetry. And this is the question that is there. You have to find out the equivalent resistance between, remember the points, this point and this point. And look at the symmetry of the diagram. This point and this point. This is just to understand the symmetry. If you understand symmetry, voila, nothing like it. If you don't understand, don't worry, this question may not come. I'll give you 2 minutes to do it. So how do we do this?
Due to symmetry, sir.
Due to symmetry, sir. Yes, that is due to symmetry, sir. So tell me the answer, sir. 3 now. Anyone has tried this? Shall I do it?
3r/2, sir.
I think 3r/2 or 3r is the answer. I'm having an answer as 3r in this. I don't know. How are we supposed to do this? Again, symmetry. Upper half, lower half. You understand symmetry? Yes or no? That means whatever is going in the upper half will come from the upper half. Whatever goes in the lower half will come to the lower half. Yes or no? That means this is not connected here. These two are connected with each other and these two are connected with each other. Yes or no?
Yes, sir.
That's it. So, and you also understand that whatever is the resistance of first half, the same is the resistance of the second half. Yes or no?
Hey, wait, bro.
Oh, this has gone above and saying bye bye, sir. Ho gaya. Enough for today, sir. Please leave us. You understand this? Huh?
Sir.
We leave us, sir, na? So R and R in series, 2R. R and R in series, 2R. 2R and 2R in parallel. It is R. So this entire thing, this entire blue thing becomes R. Then this R and this R is in series. So it is 3R. The upper one is 3R. Lower one is also 3R. So the answer is 3R/2. That is the correct answer, 3R/2. Do we understand this, or this has gone above our head saying bye bye, sir, ho gaya? Enough. We don't understand it. We are just wasting time. Do we understand this?
Yes, sir.
Now see. Now we have done this in this way. Now I'll try to use the same concept in a different way. Same concept in a different way. I take everything off so that I have the same structure again. So this is the same structure again. And see how I'm going to do this. Same concept, I'm going to just apply it in a different way. You can see these revolutionary points 6 and 5. 6 and 5 are symmetrical, so they so I can assume that they are one because they have the same potential. Do we understand this? Yes or no?
Yes, sir.
Similarly, this point 2 and 4, if 6 and 5 are same, 2 and 4 are also same. Yes or no?
Yes, sir.
But they are different.
Yes, sir.
But they are different from 6 and 4. Remember, you know? But 2 and 4, they are different from 6 and 5. But 2 and 4 are same. Yes or no? Yes or no?
Sir.
Then if 2 and 4 are also same, then this 7 and 8 are also same. They are different from others, but they are same with respect to each other. Yes or no?
Yes, sir.
Then what we can do is we can join point 6 and 5. We can join point 2 and 4. We can join point 7 and 8 because they are same. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
So if I do that, the entire thing starts to look like this. See? This pink and pink, R and R are connected in parallel. So it becomes R/2. You understand this? This
sir.
yellow and this yellow, dirty fellow, they are connected in parallel. So they are R/2. So this R and R, this yellow and yellow become that. Are we able to understand this, or this is going above or saying bye bye?
Understood, sir.
That's it. This blue and this blue become this blue. So basically all the ratios are becoming half and half. Now also you can solve it and you will end up with the same result. Do you understand what I'm saying here? This R will go with which R? Will go with this R and it is here. Do you understand this?
Yes, sir.
So this is the way you can also solve it. It depends on how you take and how you understand the symmetry. If you understand the symmetry, you should be able to solve any question in this way. Got this? Look for the points which have the same potential. If you can find the points with the same potential, remember those points which are at the same potential electrically, you can take them as same points. They are not different points, they are same points because potentially they are same, they have the same potential, so you can put them together and stay happy. We understand this?
Yes, sir.
I got one more for you. Dun, dun, dun. Any hope of getting this one? Looks frightening. Any hope? I don't see any. This is the what? Beauty of physics, my dear friends. If you understand something, you can do even the most frightening looking stuff. You can get that frightening looking stuff done. Any hope on this one, or shall I do the needful?
Wait for 1 minute, sir.
Wait for 1 minute, sir. You have 1 minute. Okay, I'll wait. So I've just taken this central resistance because I think that was a mistake in the drawing, and I've put it like this. Now, can anyone tell me how are you going to solve this? Yes, my dear friends, this is what the picture looks like now. Huh? So many hours. I'll give you 2 minutes to solve this. So we are going to do questions on infinite chain. What is an infinite chain? You will have capacitors or resistors put in such a way that they form a never ending chain. And I will try to give a question to you to make you understand. They will make a chain which would not end, and then we will have to find out the effective capacitance, or for that matter effective resistance of that chain. I'm trying to find out that question, and I think that question would be somewhere here. Infinite chain, and where is that question? This is that question, and it is taken up from your favorite book only, Infinite Chain of Capacitors. We have this infinite chain of capacitors. So you can see there is one capacitor, then the other one, then there is next branch, then there is one more branch, then there is one more branch, and this pattern is repeated infinitely. Now, what we are supposed to find out is the equivalent capacitance between points A and B. between these 2 points A and B, we are supposed to find out the equivalent capacitance. I'll give you 2 minutes to think of this and tell me your thoughts as to how you will do this, and then we will try to understand how this can be done. So I'll give you 2 minutes to think about it and let me know if you can share some thoughts. Remember, any question which is based on capacitance or equivalent capacitance, symmetry, and understanding how the pattern is getting repeated plays a very important role. So if you can understand that, probably you will be able to crack this question. I'll give you 2 minutes. Please think about it and let me know how will you solve this. I don't know the answer of this one, but how did you get it? A more important aspect is to understand how you get it rather than the answer itself. How did you get it? How did you get the capacitance as 2?
From second, let us assume as X, sir.
Okay. From second, we are going to assume that it is X. So basically what you are going to say is, if I assume that
O
the
and X are in series, sir.
Hmm?
O and X are in series, sir.
So what you want to say is, if I assume that the capacitance between A and B is X, if I assume that the capacitance between A and B is X, I go to this point and this point where the chain is getting repeated, and let me call this as A dash and B dash. From here the chain gets repeated. So basically, if the capacitance between A and B is X, the capacitance between A dash and B dash would also be X. This is what you mean to say?
Sir,
Why it is so? Because this is an infinite chain, infinite number of capacitors coming one after the other in this chain. So if I just remove one capacitor or one branch from it, that will not make much of a difference because the net capacitance remains same. Yes or no?
yes, sir.
Now, if I redraw the circuit, how does the circuit look like? So I will redraw the circuit. This is 1 microfarad. This is 2 microfarad. And this one is X. And I have to find out the effective capacitance between A and B, which is also X. So now, yes, now repeat. Now what I do?
O and X are in series, sir.
2 and X are in series. So if 2 and X are in series, I can replace them by a single capacitor. What will be the capacitance of that capacitor?
X by 2 plus X.
Correct? It will be equal to 2X upon 2 plus X. Then what do we do?
They are in parallel, sir.
Then this combination would be in parallel with this combination. So what is the effective capacitance then of these two together? 2X upon 2 plus X. It is in parallel with 1. So 2X upon 2 plus X. Now that should be equal to the equivalent capacitance between A and B. But we have already assumed that the equivalent capacitance between A and B is also X. Yes or no? So this
Sir.
2X upon 2 plus X plus 1 should be again equal to X. That will give us a quadratic equation in X. When you solve for that quadratic equation, you should be getting the value of X, which is the equivalent capacitance between A
Equal
and
to -1 or 2, sir.
so X, solving on X is coming as -1 or 2. So I will take your words for this. It cannot be
-1,
-1.
sir.
It cannot be -1. It has to be +2. So the answer for this case is +2. Well done. Everyone understood this? How is it done?
Yes, sir.
Yes or no?
Yes, sir.
Paka? Okay. Then since we have done this, I will give you one more on this so that this thing is logged and we can move ahead. The same thing could be made for a register as well. So I will give you that question, which should be somewhere here. And once you are done this, then I think we can lock up this topic and assume that we can do any question that comes in this category of problems, which is the series parallel combination. And you may expect a problem over here. It may not be directly a problem of series parallel combination, but it might be having something to do with a series parallel combination. That is what I expect, because they have to give a problem on circuits no matter what. A problem has to come from either capacitor or resistor, and if you're lucky, it might come from both capacitor as well as resistor. So meanwhile, I've taken a long journey and I have come here this question. Now once you are able to solve one part of the question, I don't know if you can solve the next part of the question, but even if you can solve the one part of the question, that is good enough. This is the question. This is taken from your book, and solve question number 46 or something like that. Can you solve this? Now once you're able to solve this, then the next part comes. An infinite ladder is constructed with 1 ohm and 2 ohm resistors as shown in the figure. Find the effective resistance between the points A and B. Once you are able to do that, find the current that passes through the 2 ohm resistor which is nearest to the battery. I'm not expecting that you can do that, but can you find out the equivalent resistance? We will only concentrate on that part. I'll give you 2 minutes to get me the answer. So how are you supposed to do this? Again, you will have to look at the symmetry of the diagram, and I will again call the resistance between this point and this point as R. Then you just move and see from where the pattern is getting repeated. So I can call this point as A dash and this
Sir,
point as B dash. Yes, beta?
distance is -1 plus or minus root over 13 by 2, sir.
Okay, I don't know. I will have to check the answer from the book. I'll have to see. Let's see. So I can call the resistance between A dash and B dash also as R. Yes or no? Because if I just remove one branch, that is not going to make much of a difference. Now if I draw the remaining circuit, the remaining circuit would look like this. Tung 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 tung. So this is 1 ohm, this is 2 ohm, and this is going to be R. I hope I have not done a mistake. Yes or no? I've done it correctly, yes or no?
Yes, sir.
Now I can see these two are in parallel. So these two are in parallel, their effective resistance becomes 2, oops, wrong color. I hate wrong colors. What is happening? 2R upon R plus 2. And then this would be in parallel with this one. So plus 1. That must be again equal to X. And if I can see it correctly, this is the same equation as the equation we got in the previous case. Yes or no?
Yes, sir.
So if the answer in that case was -1 and 2, the answer in this case will also be -1 and 2, unless someone does a big mistake. You understand this?
Yes,
This is
sir.
Kaun Ababa saying bye bye. Bye bye, sir.
Understood,
Bye
sir.
bye. Okay. Now these are the problems that we have done, and I'll show you the problems that have come in the previous 2 years. So this is the one that has come in the year 2021 or 22. I don't know the year because the year is not there. 5 equal resistors are connected in the network as shown in the figure. The net resistance between point A and B is. Yes. Do we have anything that looks like an answer? Yes or no? No or yes? So tough? Oh God. It is such a tough question that everyone is looking here and there.
Sir, option 4.
Option 4. A. R is the answer. What is this, my dear friends? This is our old friend, new friend. Balance Keystone Bridge, yes or no?
Yes,
Yes,
sir.
sir.
What they have done that they have put B inside like this. You just take B out like this. Doesn't make any difference. And you take A on this side. If I take A on this side, it looks like this. This goes Bhagwan ke paas. And this point A is here. This is basically a balanced Keystone Bridge. Yes or no? No, yes. Huh?
Sir.
So the answer is?
R.
Answer is R, 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 R. So many R, not 3 hours. We have got 10 hours. And I hope you understand that the question which are going to come are going to be pretty damn simple. See, this is the question that came in this 2021 year. In the given figure, switches S1 and S2 are in open condition. The resistance across AB when the switches S1 and S2 are closed is how much? I'll give you 2 minutes to solve this. So how are we supposed to do this? Switch S1 and S2 are closed. Switch S1 and S2 closed means this 12 and this 6 will come in what? Parallel. 12 and 6 in parallel becomes how much?
4, sir.
4 na? This switch is also closed. So 4 and 4 come in parallel. It
Sir.
becomes 2.
2.
This also
Sir,
come. This also come in parallel. It becomes
4.
That is the answer. Whatever it is.
Sir.
See? So the moral of the story is very simple. What is the moral of the story? If you do things simply, you should be able to get the answer. One question from IIT, old IIT, but still IIT. To find the capacity. Why I'm doing this question? Because you never know, the same question will get repeated. You never know. Capacitance from IIT. In the figure, find the if the resultant capacitance between A and B is 1 microfarad, what is the value of C? So question is asked in a different way. Question being asked in a different way. I hope you can handle this. I'll give you 2 minutes to do this.
Sir.
Okay. So I will again repeat the entire question. The entire question was like this. The entire question was like this. The effective capacitance C effective between A and B was given as 1 and then we had to find out the value of the capacitance C. Do we understand this? The effective
Yes, sir.
capacitance between A and B was given as 1, and from there you had to find out the value of C. You can do this, yes or no? You can do this, yes or no?
Yes, sir.
I'll give this as homework. The value of C, that is what we are getting, is the answer is given as 32 by 23 microfarad. You can solve this. This is a very simple series and parallel combination, yes or no?
Yes, sir.
So solve it and check the answer. Now what we are going to do is we are going to get into the last category of problems, and the last category of problems is plate connection. I call them plate connection problems. Now what do you mean by this plate connection problems? The problems would be like this. They would give you some plates, capacitor plates. The area of the plates, let us say, will be given as A, and the distance between the plates, let us see, would be given as D. Then what will they do is they are going to connect these plates in such a way that, let us say, this is connected. Let me not draw this first. They will say that oops, 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 oops. Okay, they will connect the plates. I don't know what is happening with this. Okay, they will connect the plates. Let us say this plate and this plate are connected to this point X, and this plate and this plate are connected to the point, let us say, Y. If I name these plates 1, 2, 3, and 4, they will connect the plates to each other in different ways. Here, plate number 1 and 3 are connected to point X. Plate number 2 and 4 are connected to the point Y. And then they will ask you find out the effective capacitance between X and Y. What is the effective capacitance between X and Y? How are you going to solve this question? Plate connection questions. Now remember, to solve this question, you have to first understand how many capacitors are there. How many capacitors are here? This is pink capacitor between plate number 1 and plate number 2. This is capacitor number 1. Then there is a capacitor between plate number 2 and plate number 3, the green capacitor. Then there is a capacitor. There is a capacitor between 2 and 3, the green capacitor, and then there is a capacitor between 3 and 4, the blue capacitor. So there are 3 capacitors. Do you see these 3 capacitors? Yes or no?
Yes, sir.
And the plate area is A. They can give different distance of plates, but normally they will give the same. So the distance between the plates is D. So basically, the value of each capacitor, the capacitance will be epsilon naught A by D. Do we understand this?
Yes, sir.
You can call this as C. So all the capacitor will have the same capacitance C, C, and C. There are 3 capacitors here, and they are asking you what is the effective capacitance between X and Y. Now, how are you going to solve such a question? I will solve this for you, and then I will hope that you can do the next one. How I am going to solve this? Remember, I have to find the capacitance between the point X and the point Y. So basically what I'm going to do is I'm going to arrange it in a way where I understand. Now, how do I arrange this? I start from the point X and I just start connecting the plates in the way that they are connected. Now, you can see this plate number A, plate number 1 is connected to point X. So, what do? I connect plate number 1 to point X, and plate number 1 and plate number 2 make a capacitor. So I make this capacitor. So now I have here the blue capacitor. Now I have the pink capacitor here. Do we understand how I got this? Yes or no?
Yes,
Yes,
sir.
sir.
Now you can see this plate number 2, my dear friends. Plate number 2 is connected to point Y. So what do? I just connect this plate to wrong color. I hate wrong colors. Now I connect this plate to point Y. So what I have done, I have drawn the pink capacitor, and this is how it is connected. We understand this? Yes or no?
Yes,
Yes, sir.
sir.
Then I will go and do the same thing with the green capacitor. Now green capacitor, one plate is plate 2. Plate 2 is connected. So I have to connect it again. Plate 2 is connected to point Y, and plate 3 is connected to point X. So I will have to make one more plate here. I make one more plate. This is the green capacitor, and this plate 3 is connected to point X. So I connect it here like this. So far so good. Are we able to understand this?
Yes, sir.
Then I have to
Yes,
make
sir.
one more capacitor, the blue one. So I repeat the same step. Plate number 3 is connected to point X. So I have to again make plate number 3. And plate number 4 is connected to point Y. So I can connect it anywhere it is connected to point Y. I get my blue capacitor. Now you can find out the effective capacitance between A and B. What will be the effective capacitance between A and B? You can see it will be simply equal to 3C.
VA epsilon naught by D, sir.
Yes, 3C you can call it simply. Do we understand how this is done?
Sir.
Pakka? So
Okay,
basically
sir.
what you have to do is simply connect the plates and do nothing. Just connect the plates and you are done. We understand this, yes or no?
Yes, sir.
Can I expect that you can do? Remember, the connections will not be same in all the cases. The connection would be different in different cases. So you will have to understand how they are connected. Can I give you one problem and then you can do it for me? Everyone has understood this? Yes or no?
Yes,
Yeah.
sir.
So I am now devising a problem for you. And I hope that you are able to do it for me. All the plates have same area A, and the distance between the plates is given as D. You have to find the effective capacitance between A and B. How many plates are here? Huh? How many plates are here?
4, sir.
4, sir. How many capacitors? Huh?
3, sir.
3, sir. You can name the plates 1, 2, 3, 4. My favorite pink. My favorite green. My favorite blue. Can you tell me the answer of this one? You have 2 minutes to do it. So, how are we supposed to do it? Let's try it. I start with the point A, my favorite. A point A is connected to the plate 2. So, here comes my plate 2. Now, 2 and I can go to 2 and 3. I can go to 2 and 1 as well. So, I make 2 and
C by
1.
3, sir.
Yes, beta?
2C by 3.
Okay, it may be possible. I don't know. I just drawn the figure. So I get the pink capacitor. Do we understand this, everyone?
Yes, sir.
Okay. Now this plate 1 is connected to plate 3. So I must connect this plate 1 to plate 3. Plate 1 is connected to plate 3. So I make the plate 3 here. Now 3 and 4 also make a capacitor. So I make 4 here and I get my blue capacitor here. But this plate 4 is actually connected to point B. So I'm done with the two capacitors. The pink one and the blue one. The green one still remains. Now the green one is between 2 and 3. So what do I do? 2 is connected to point A. So I get 2 here. I get 3 here, the green one. And this 3 has to be connected to 1 or it has to be connected to again 3 itself. So I can just connect it like this. And this is the connection that I get. The pink one and the green one are in parallel. C plus C, 2C. This 2C and C are in series. So the answer is 2C by 3. That is absolutely correct. We got this, everyone, boys and girls.
Yes,
Sir.
sir.
Everyone got the answer?
Yes, sir.
Sir.
Well done. Then congratulations. This was one of the tougher parts of this. You could understand this. Congratulations. With this, we will come to an official end of your series parallel combination. In the next class, we will move on and solve some circuits in capacitor, and if possible, we will also try to take the circuit of resistor and together we will solve them. Why? Because we don't have time to do them separately. So we'll try to solve them together. Because we can understand that everything is same. Yes or no? Huh?
Yes, sir.
So basically, we are doing two topics together. We are doing capacitance as well as resistance together. Some part of resistance would be left. That as soon as we finish with capacitance, then we will take care of that part. Okay?
Sir.
Yes. Beta?
What's the next chapter, sir, after this?
Current. Then magnetic field. Magnetic effect of current. Why? You want to do anything else? Okay.
Thanks, sir.
Chalo then. So we'll meet in the next class and we will start with the circuit thing and we'll do capacitance and resistance together. So take care and I'll see you in the next class. Bye bye everyone.
Thank you, sir.
Thank you, beta.